I think, Franklin, I don't know if you can speak about it, but I think it's great that you speak because this was one of your ideas, which is the feature, additional feature, what is called a feature engineering. You're welcome to speak over it. But what we're going to try to add here, it's a bit of more features that we think that might be useful to calculate. For instance, we know that we have a gas oil ratio. So rather than probably using the production volume or the gas production volume, or rather than using the water production volume, we can use the GOR and the water cut that are more bounded in a way than the volumes of a production of a well. So in this case, I can add the GOR, and I can calculate the GOR as my gas volume divided by the oil volume. And I can calculate the water cut as my water volume divided by the sum of divided by the liquid volume, which is water plus oil. Okay, so let's copy this here plus this. So now we have a water cut GOR by, and this is also very important because we remove the oil volume. We are going to make sure that we don't have any silly infinite values of GOR or water cut over there. Okay, so there we go. We have a couple of new features there. And if we added those, you can imagine that then what we need to do is drop. Yes, we need to drop the gas volume, and we also need to, and we also need to drop the oil volume. And again, this is on the axis 1, which is the columns. Okay, so if we see the info now, we see that we have now GOR and water cut. Oh, I dropped the oil volume, sorry. I dropped the oil volume. I dropped the oil volume inadvertently. Okay.
Alejandro?
Yes. Yes.
Quick question here. The dropping for some features, is it to avoid collinearity or for another purpose?
In this particular case, it's because we in the particular case of the features such as let's go back to some of the features that we have here. So some of the features we have things like field name. So that's a unique value. Field code, that's a unique value as well. So there is no need to add a feature that is constant across the whole data, or the facility name, facility codes. These are obvious ones. So some of the well code is also, it changes with the well name. So the well ID has no correlation to any property. It's something that it's an incremental of a previous well ID. So it's not, or these choke units. That's in terms of dropping some of those columns. And the other one is in terms of collinearity. So one thing that I didn't plot, but you will find a strong collinearity, and it's perfectly aligned, is this feature that I dropped here. Where was that? Sorry, just hear some noises. I forgot, I cannot find it. So the feature of this choke. So we have a choke, and you can see that these are strongly correlated. So you either put one or you put the other. So that is one of examples of which one do you prefer to put. And that's it, yeah, in this particular case. And the features, the rows that I'm deleting, it's because we don't want to predict we want to predict only when the well is open. And we don't want to make a model to predict when the well is shut. And in fact, if we do that, I prefer to build two models, one model when the well is open, one model when the well is shut. So it's two different models. Okay. Sorry about that, and hopefully this should be fixed. Yes. And what I'm going to do here is drop the water volume, not the oil volume. Okay. So now we have oil volume, GOR, and water cut. And this is also what is called a bit of efficient engineering. This is very simple, what I've done here. But you may think of something more advanced and some correlations or equations that you may want to introduce here and add those calculations as features later on in your model. And this is a very important part because this is part of the domain expertise that you can put into your machine learning model. So the other thing that I'm going to do is I'm going to add something called the wells to fit. And I'm going to add the first two wells. They look quite different in the performance. So I'm going to take the first two wells. That would be something like this, I guess. Let's see. Well names. Okay, that's only one. Let's say two wells. Okay, I'm going to add these two wells, and I'm going to fit a model with these two wells. And the idea is to train with those two wells and then use it on the next model. So for my predictors, I have a list of things that I would like to use. And Franklin, do you have any? I know that you dropped the casing pressure. Do you have any particular reason? If you can probably write on the chat, or was it any particular reason for dropping, or should I put it back? Okay, I think we're gonna carry on without that one, but we dropped the casing pressure, and it's something that we can try later on and include it.
Yeah, can you hear me?
Yes, I can hear you now.
If I remember well, the main reason for dropping the casing pressure is that we don't find reliable data for the casing, so it might not be important for the calculation.
Okay, so actually, let me add here in the plot casing pressure, and then see. Let me check. Oops. Oh yeah, there's something.
Yeah. Also, casing pressure is a variable that might be. We need more specification to understand what casing is referring to. So we might be dealing with different type of information. It's better to drop it if you don't know.
Okay. Thank you. Okay. Sorry. One step before I set up the predictors that we're going to use for the model, and I would like to get a data frame with only these wells that we want to fit. So I'm going to call it a data frame with the training wells. So these are the data set, the data frame with the training wells. And I can use the original data frame. And we're going to filter well name. And this is a trick that we can use. We can use isIn and then pass a list of wells that we want to filter by. So in this case, these training wells will only contain, this data frame will only contain data from these two wells. Okay. So if I do that, I know the name of my predictors, And this is where I'm going to start to talk about machine learning.